see this. Write a function distance that would take 2 point coordinates x and y as input and returns the Euclidean distance between them. Note that in distance, the points x and y should be considered as tuple. So here what we can do is we can define a class, say point, which will be containing two values, say x and y. And as we have discussed, in during this class, during discussing this, so there is a function called double underscore init double underscore that is kind of a similar to a constructor. So we will be defining a similar constructor here, just like this, which is a function, init, that is short form of initiate, that will be taking basically three parameters, the self and the x coordinate and y coordinate, and then it will be using this self as to define the corresponding thing. So here what we are doing is, so this is a constructor calling this function, calling this class with two variables, it will make one. So let's just, other than talking, let's do this practically. So here what we can do, what we have seen here is, so here in this example, this complex number examples, there are two variables, that is real and image, and one function that is called get data. And note that this get data is kind of working on this data, working on this variable. All right, so let's try to, so to define, as we have seen, we need to call this, we need to define, we need to use the same class name here, and we need to pass the corresponding variables, that corresponding values that we want to assign here. So for example, here I am defining one p that will be a point which will be containing, say, 5 and 7. So now if I print the type of p, you will see it will be point. Note that it is underscore underscore main, because here this is the main, this is the main function here. So as we have discussed, there is no as such main function here, but at any point if we print the corresponding name of the thing that is actually generating, so it is called, I think, name. So it will be printing the main thing. So basically here in this class, this point, this class point is defined inside this main module. Not module as such, module that we have discussed in Python, but this point is inside this, this you can say the main function. But note that there is no main function as such defined here, but the name is considered as main. As we can see, we can use this underscore underscore name to check what type of name it is. Now, can someone please help me write a function, say, so the same thing that was there in here, distance, that will be computing the two distance, basically distance between two functions. So as we have seen here, to declare, to get, to work on the one object of this class complex number, we need to pass this self keyword. So that's why I need to use this. So now can someone help me to write this Euclidean distance function? How will it be working? So it will be returning the value. So it will be returning the Euclidean distance between two values. So how can we do that? Someone please help me. So self will be the invoking function, but to to get the distance, we need two instances, right? So one will be, say, p1, and another will be, yes.
Sir, so through the self over there in the argument, x and y will be invoked.
Not actually x and y will be invoked. So
I mean, we
let's
need to get the points to
so
compute the
let's
distance.
let's let's just again walk through this. So here, so it's not actually a thing. So let's define say 12 comma say 17. So here this statement will call this function and this 5 and 7. So here self will be p1, x will be 5 and y will be 7. But note this x is 5. Sorry, this x, the one here is this 5, not this x. Initially self x is not defined. I am defining one variable inside this self. Here self is an object of this class. Mind my every word. Here self, in this example here p1 is the object of this point class, and this point 1 is getting passed here in this init function. Here again this p1 is getting transferred here as self. So self is basically the object of this point class. And so far there is, I mean, before this there was no defined variables inside this point class. So now I am kind of defining as well as initializing basically two variables. I'm naming them as x and y, and I am initializing them using this x and y. So to keep everything less ambiguous, let's make them a and b, a and b. So basically with this statement, I am basically calling this init function with p1, then 5, then 7. So p1 is getting transferred here as self. Sorry, init. This p1 is getting transferred here as self. 5 is as a, and 7 is as b. So if I just print the value of a and b here, you will be see first 5 and 7 will be getting printed, then 12 and 17 will be getting printed. So here again this statement is calling this function. We can also print some statement like constructor called constructor called constructor called with say a comma b. Let's so constructor, this function is getting first of all called with this 5 and 7, and then this with this 12 and 17. Is it clear now? I mean, how this function calling and all this everything is going on.
Yeah, okay, sir.
I mean, if you still have some doubt, please ask some questions. So again, I am repeating, I am declaring one class here. Here, this is a class. Here, I am making some objects. So while defining say s1 equals to hello, I am doing the same thing. So here, hello is a string, and I am basically defining an object of a string class. So why this is different? So here for this user defined, so as you can understand, this is a programmer defined class, but string, that is str, is the Python developer defined class. So they had developed the string class in a way such that we can use this kind of notation to define a variable, define an object of string class. So basically, any statement A equals to B will be resulting in one creation of an object of string class if B is containing something in quote, either in double quote or in single quote. Sorry, either in double quote or in single quote. So they have, as it is Python developer defined, so they have done this in this way. But for this user defined or programmer defined, it's mostly called user defined, as we are the user of Python, so it is basically user defined. So this is a user defined class where we are defining, this is the name of the class, and to use an object here for string I was defining like this. here to define an object of this point class, I just need to invoke this. And also, as we are discussing, to define one function, we can of course define some function here as well, and we can pass some values here as well. So a and so p1 and p2, and we can of course use some operations here as well. So is it clear, or shall I write this Euclidean distance function here? Will it be helpful for you guys? So basically, my intention here is to, so I'll be calculate the Euclidean distance, Euclidean distance between P1 and P2, and it will be and return the value. So here, this P1 and P2 will be basically two objects of this class, and we will be writing the same thing. We will be writing the Euclidean distance here in this body, and the last statement will be some return statement, which will be returning this dist. So in between, we will be declaring some dist as equals to the Euclidean distance. So you can write it. And while calling it, I just need to call it using, say, P1 dot distance, and then as it is expecting two variables, I need to pass two values as well. Also, it can be written in another way, which is, say, define distance. I'll be taking only one value, one parameter here. So for example, I will be passing, say, only the P2, because P1 is, as you can see, P1 is getting passed as self it is. So as we have discussed, we should have this self parameter. So this statement, so basically if I want to call this, so I need to call this P1 dot P2. So here this is essentially similar to calling of this point as distance is a function defined in this class variable. So this class name point, and then we are basically passing P1 and P1 and P2. So as it is, you can see it is redundant, as self is always getting passed. So we can kind of remove that redundancy here, like here. So another way of calling this, so we can call this distance 1 and distance 2. So distance 1 and P1 dot distance 2, we just need to pass P2, which is similar to calling the function point with distance, sorry, with only P1 and P2, because P1 is by default getting passed as self. By default getting passed as self. Extremely sorry, yes, now it is. So this function, this statement is calling this function. As we are passing two values, the invoking the calling object is also getting passed here, and it is taken here as self. And here in this example, in this function, I am passing only one parameter here. In this invoking, I am passing P2, which is essentially as self is, as the invoking object is by default passed as self, it is equivalent to this. Is it clear? Or shall I write this? I mean, it will be easy, but I mean, I hope you will be able to write this. Just to write the same Euclidean function like P1 and P2, we need to access the corresponding thing P1 dot x. So as we have seen, so let's define another function that will be easy. So display point. So again, self will be there, and it will be, so let's print that the point is self dot x. Let's have in this way, and then in quote, single quote, and then self dot y, and then single quote this. So here, so this function will be just displaying the, just printing the at an individual point. So if I just call them with p1 dot display point, we will be printing. So the point is, so as you can see, p1 is initialized with this 5 and 7, and I am calling this display point function using this p1. So this statement will be calling this statement. Here self is basically p1, the invoking object, and I am printing the value of x and the value of y of that invoking object, which is p1. So I am just printing that thing. Is it clear now?
So, what is the utility of doing this when we can do it in a normal way in a short form?
The main utility of using this is called encapsulation. So basically, you can straightforward use this point class from anywhere. And you know, so not you know, but I mean, as you are developing this, so you have developed this kind of definitions like this display or distance inside this point, inside this class. So you can simply call the corresponding function, either say p1 dot display or p1 dot distance between two points. You can simply use them. Otherwise, what you need to do is you need to define a function which will be doing those things, and you need to put all these functions separately in every program that you are doing. And also there is, I mean, the main concept of this object oriented programming, as Python is an object oriented programming, the concept of encapsulation. So what we are doing is we are encapsulating the variables here in this example x and y, and the functions, for example here this distance or this display, we are encapsulating them together. So this function will be, so basically to use this, to use an instance of this class, we just need to define an object. We just need to define one object of this class, and we can use all the corresponding variables here, in this case x and y, and the corresponding functions as well. So let's write one solid program that will help you to understand this. So let's define one function, say what we discussed earlier, say swap. So what we have done is, so c equals to a equals to b, and b equals to c, right? So like this, we, if we want to swap these two variables, this is the code to do that. So now let's define x equals to say 10 and y equals to say 20. Now let's print x and y here. Now here print say a and b, as a and b are the variables, and now call this swap with x and y, and now print x and y here. So can someone guess what will be the output? So there are three print statements. So if I enable the line number, so first this print statement will be executing. I mean, the first output will be this, then this, then this. So what will be the output? What will be the output of this? Please, someone, what will be the output of this?
So, things are unchanged.
So 10, 20, right?
Yes.
The next is this. What will be the output of this?
It will get swapped after the
So
function
basically
is
A will
called.
be 20 and B will be 10, right? So what will be the output of this here? Anyone? Come on.
1020.
10, 20. So now if I execute this, 10, 20, 20, 10, 10, 20. So first this, then this, then this. So as you can see, we are calling this swap function with these two instances, but they are not actually getting swapped, right? As you can see, Now what we can do is we can define a class, say again say, so we can reuse this. No, not, it should be okay to not use that. So let's define another class, say numbers, and define one constructor A and B. Now let's define another function called swap, which will be taking self and another number, say n, and it will be doing the same thing. C equals to self dot a. Oh, sorry, it should not be there. Two variables, it should be one variable. And self dot a will be n dot b, and self dot, sorry, n dot b will be, so can someone guess what I'm doing here in this function? So better to write again one program. So let's define n1 equals to number, then 10. So what I'm doing, oops, some error, number is not defined. Oh, it's numbers. Let's make it number. So here what I'm doing is I'm defining one class, I'm naming it as number, and here I'm doing something here. I have defined one constructor here, initializing the value of this class number, which is containing only one variable, here in this case a. And here this swap function is swapping two numbers. So now I am defining another variable, say n2 equals to number 20. So if I now just call, say, okay, let's have it in the same cell. So if I print n1 dot a and n2 dot a, you will see n1 dot a is 10, as we are calling with 10 and 20. Now what I want to do is I want to swap them. I want to swap the corresponding value there in n1 and n2. Okay. Now what I need to do is I need to call the swap function with one of the number, one of the object of this number. I am using n1, so I will be passing n2 here. So this is basically n2 will be n here, and this self will be n1 here. Is it clear? So this statement will be calling this function, and here I am just swapping them. Now if I execute this, you can see that actually the number is swapped here. Earlier while swapping, you can see it's not actually swapped. The actual values are not actually swapped. But in this case, as we are encapsulating the things, so here in this encapsulation, basically in this class, I have encapsulated two things. First is this variable a, and second is a function that will be working on these values. Note my word, these values. I'm using a plural because this swap function is taking two parameters, and these two parameters are two objects of this class. What I am doing is, again, I'm essentially working on these variables. So these are again this a. So in number, there is only one value, one variable that is named as a, and one function that is named as swap. So I am using this swap to operate on this a. So basically what I am doing is invoked with one with one object and passed one another object. I am just swapping them. So initially we had talked about uh, call by value and call by difference. We have discussed about this. So why it is not actually getting reflected. So at that point, this discussion was left as well, like how to, I mean, how to get this kind of output after, I mean, outside this function call. So initially, if while we are using this definition here, we are not actually, this function is not actually swapping the values. So x and y values are were remaining the same, but using this encapsulation, using this class, we can actually swap them. This is a very simple example of using this class and how, I mean, at which places this will be useful. So again, in case you have a large, I mean, so basically if you have, if you want to define some variables which will be having multiple perspective, like here in this example, complex number which will be having two variables like real and imaginary, uh, and I mean, similar to these cases, you can use this. You can use this class to kind of encapsulate everything together. Is it a bit clear now? The better example was with this point. So here in this point, I've already discussed. So I hope it is much clearer now. Is there any question? Please, please, someone ask some question. I hope I'm online, right? Yeah,
Yes,
am I
sir, you're
online?
all.
Okay. Okay, so yeah, so I hope it is okay, right? I mean, I'm considering this silence as an affirmation, or shall I take it as a negation? So please, I mean, please try writing some class yourself. I will request you to complete this class. So I haven't completed this distance function here. I have written some other classes as well. So considering them, just it's a simple thing. That's why I haven't written this here. So you just need to define the corresponding Euclidean distance function, the norm, the distance, and the square root, everything here. So basically, there will be 2 points p1 dot x, p2 dot x, and p1 dot y, p2 dot y. Then based on that, you just need to compute the distance, and this distance will be a floating value, which will be containing the distance between these two points in this two-dimensional plane, the Euclidean distance. Is it okay? I hope it is okay now. So, any further question regarding class or other topics?
Sir, today or tomorrow, either way that suits you. Could you once again explain that defining user defined, I mean, designing own programmer modules, and I mean, we can make it, but how to include it in program so that we can use it that part.
Okay. So,
Yeah,
shall
today
I
or
do
tomorrow,
that today or tomorrow?
as
Whatever
you
you
wish.
prefer.
It's not a problem for me. Anything which suits you.
So let's today start discussing about a little bit recap. So I have planned on. So there are some things that are left to be discussed. So let's I mean, use tomorrow's class to do the recap as well as defining, as well as discussing on this module on how to define and where to place them. So yeah, we can do that tomorrow. Okay. All right.
Yes, sir.
So basically we started with uh, uh, what basically a computer is supposed to be doing. So we discussed about the different components in a computer. So also we have defined what a program is. We have defined how to, I mean, it's a simple program on how to get the square root of a number. This was the program development phases. There are basically 5 phases that we discussed. We also discussed different types of programming languages. Basically, we have defined them, we have segregated them in two different, from two different point of view. One is low level, one is high level. Low level means it's more close to the hardware, actual hardware. and high level is, it is in between. There needs to be some low level languages that will be converting these high level languages into the corresponding machine languages. So we also discussed about, briefly discussed about, differentiate about these two, a high level language which is a Python, an example on Python, and a low level, an assembly language of the corresponding thing written here in 8085 language. So we have discussed about the I mean differentiated about how the high level language and low level languages are different. These are some of the examples. Oh, sorry. So types of, so high level languages can be differentiated based on the way they are executed, and the way they are actually transformed into machine languages. So based on that, these high level languages are differentiated between compiled languages and interpreted languages. So Python was an interpreted language that we have discussed. So we have discussed regarding this nice example on how this compiler and interpreter works. So we also, I mean, this was a formal table to display that, to place the advantage and disadvantage together in a simple table. So there are basically, so interpreted languages are very slow as we have discussed. So basically, can someone say what is the reason that interpreted languages are slow? One of the main reason. I mean, I hope using this example you will be able to recall that. So why interpreted languages are slow in terms of execution as compared to compiled languages? Come on, this type of questions will be asked during the Viva. So can someone say what we, I mean, why interpreted languages are slow? Come on. All right.
Sir, I can try a bit.
Yeah, please go ahead.
Interpreter runs slower because they need to analyze and find out what each statement in the program
Evaluate.
code yeah
Exactly. So
is
they
written.
needs to evaluate every single line individually. So if there are 10 lines in the code in the program, compiled language will convert the 10 line code into a single statement, single, not single statement, but a single set of machine readable code. But for interpreted language, it will be converting the first line in the beginning, then second line, then third line, and immediately all the lines will be will be provided to the machine as well to execute. So that's why, as it is executing line by line, interpreted languages are slow as compared to compiled languages. So high level languages are, from another perspective, they can be divided into three different languages: structured, procedural, and object oriented. So we had focused on Python, which is an object oriented programming language, as well as procedural languages. So we used this Anaconda to do that, to write codes mostly. So I hope you, I mean, most of you had used the same. So we discussed about how to take inputs and how to provide outputs from a program. So we discussed about, briefly discussed about complexity computation as well. We have seen that the time is the most crucial one in terms of evaluating two programs which are doing the same job. So we kind of we have taken this square root finding function to check two different implementation of the same function, to implementation of the same program, which is, one is doing pretty fast and another which was doing pretty slow. So to do that, we have discussed about this using this magic command time it. So the main elements of Python was, any programming languages were the vocabularies or the words that will be used for writing a program. So basically, these were the reserved words. Also, using these reserved words and some identifiers, we will be forming some valid syntax, valid statements, which will be similar to, which are similar to sentence structures in English. And the story structure in English or any human readable language is equivalent to the construction of a total program. So storytelling and doing something is kind of similar, as we have discussed. So keywords and identifiers. So these are the keywords. In total, I think there are 33 keywords defined in Python 3.6.9. There are four other keywords defined after that as well, which were not discussed. So here we have looked at most of them, but we kind of overlooked some of them. So we have discussed false, class, finally, is, return, none, continue, for, but we had looked, I mean, we never looked at lambda. Then we had looked at try, true, def, from. We missed this non-local. While we have discussed and, del, global we had also discussed, not, with, as, elif, if, or we have also discussed, but yield we haven't discussed yet, and assert, and rest of the rest of the keywords we have discussed. So let's try to use them.
Sir, pass is also not discussed.
Oh, pass
Pass.
is also not okay. So pass is a statement which is kind of used to just, I mean, used mostly for debugging purposes. So let's discuss pass as well. So first, let's discuss the five things that we have, mostly four things, four keywords which haven't discussed yet: lambda, non-local, yield, and assert. And then we'll be using, I mean, we'll be using this pass to write some codes. All right. So first of all, it's a lambda. So lambda is a lambda function, as some of you might heard. So lambda functions are used to create anonymous functions. So lambda functions are just used to create anonymous function, that is functions without having any name. So for example, let's define a lambda function like lambda. As you can see, it is, the color has been changed as it is a keyword. So let's define, say, y. So basically this is the syntax. So let's, I don't know, so let's make it, say, square or say cube. So this is a lambda function which is I mean, so basically this is the parameter and this is the statement that it will be returning. So it would be an inline function, that is, in single line it is defined as well as, I mean, mostly defined, and we can use it for from anywhere. Not from anywhere, but I mean, from the immediate statements we can easily use them. So let's kind of I mean, use this lambda function to make the cube of a number. So let's define a for loop, say for I in, say, range, say 5 from 11, so 5, basically 5 to 10. So if I want to check the corresponding cube of individual numbers from 5 to 10, I can simply use x. Basically, this is the name of the lambda function here, and I need to provide the corresponding variable. So here I is the variable here which is getting passed to y, and this y, basically this passed I, will be operated on in this statement here, and the corresponding output will be returned immediately. So if I execute this, you can see these are the output that I am getting. So if I also print the value of I here, so for I5, so this function is, so this 5 is getting transferred here, and this cube is performed here using this statement. And as this is the function, basically the lambda function is named as x, so we need to call it using this notation. So also, if we want to use two parameters to pass, so for example, let's define another lambda function, say lmb. So let's define it, say, so for example, I want to define a function which is equivalent to this. So add a comma b, which will be just return, sorry, return a plus b. So if I want to do an equivalent function, if we want to write equivalent function using lambda function, what we need to do is, again, we need to provide two parameters here, in this example a and b, and then the statement that will be returned here will be a plus b. So now if I just call it using ALMB, so basically this is the function name, the lambda function name, and if I pass it say 10 and 15, it will be printing the 25. So this lambda function is equivalent to this function. So now you will be wondering, why should we be using this lambda function? So basically there will be some cases, I mean non-complicated cases, where you will need to use a simple statement inside a function. So as we have discussed, I think we have discussed that there we can define a function inside a function. So in those cases, these lambda functions come handy. So basically you can simply define a lambda function inside a function which will be doing something or the other. So this add, let's define that this add will be returning the say cube of this number. So basically it will be returning say a cube plus b cube. So to do that, we can define one lambda function inside here, which will be kind of making the corresponding cubes. So it will be taking one parameter here and making it, I mean, returning the corresponding cube. And here it will be the final return from this add function will be LMBD, sorry, LMB, and then A plus LMB B. So now if I call this add here, and let's give some smaller output, say 2 and 3, it should be returning the a cube plus b cube, the value of a cube plus b cube. So here I am just defining a lambda function which is just giving me the cube. So LMBA, so from this statement, this function is getting called, and here I am defining another function, and this function is a lambda function which is inline, as you can see, it's a single line statement. And this statement is calling this function as LMB is the function name. I am passing the value of a, which is 2, and it is returning 2 cube, that is 8 here. And I'm passing, I'm again calling this lambda function LMB using the second parameter, that is 3, and this value of 27, the cube of 3 is returned from here. So 8 plus 27, 35 is the final output. So yes, it is kind of a little bit confusing why we will be using lambda function. Of course, let me tell you this, that there, I mean, all the situations can be handled avoiding this lambda function as well, but it is worth knowing. I mean, there will be so many cases, advanced program, and I mean, if you look at some complex advanced programs, you will be coming across this lambda statements. But again, I am repeating that we can avoid using this lambda function as well. But sometimes it is better. I mean, not the best, but it is the better. It is a better solution to use this lambda function. Okay, so another thing that we have left discussing is non-local, this statement, right? So let's write some programs regarding that as well. So let's define one variable, say global. So let's name it global S. Let's define a function here, say f1, say, and let's define the same variable s as local s in f1. Define, say, another function f2, and let's define another thing. So now if I print the value of s here, and say if I call f2 from here, and if I print s here as well, I don't know what what, how is it will look like? Okay, it should look like fine. And now if I call f1 from outside, and now if I print s here, so can someone say what will be the order? I mean, which statement? So there are three prints in line number 6, line number 8, and line number 11. So what will be the first output? So which print statement should be executed first?
Sir, in F2, there will be common, you have given semicolon
Sorry, which one? Oh, sorry.
in defining F2. Yeah.
Yes, extremely sorry. Yes. So which print statement will be executed first?
Line
First,
6.
line 6 would be executed first, right? Why?
Yeah.
Because from this statement, so basically this statement will be executed first. So f1 will be calling this function. From f1 there are basically first this line, then this definition, then this function call. So this function call will be executing this. So first line 6 will be executed, basically printed, then 8, then 11. So if I execute this, you can see in line 6 we can see the output is local sf2, this one, basically this variable. So here I am printing this variable. In this line 8 we are printing this variable, and in line 11 we are printing this variable. Now what if we want to access this variable from here, or this variable from here? So first of all, to access this variable, this s, basically this variable defined inside f1 from this f2, what we need to do is we just need to use non-local, this keyword here. So now this s1 was initially local sf1, but after these two statements it will be printing, basically this statement will change this local sf1 to local sf2. So this statement, basically this print statement will be changing. So this statement will be becoming the same. So these two statements, both of them will be local s f2. So let's execute this. So you can see both of them are the same output, you can see local s f2. So the reason is, so local non-local s is kind of uh, stating that the immediate s, the variable s will be referring to one non-local, basically. So basically without this statement, this s will be considered as a local variable, but with this statement it will be considering the s as a non-local variable, which is the immediate one, which is this. So using this we can kind of, we are overwriting the content. And as we have discussed how to change this we have discussed using global. So how to do that? So simply we can use, I hope you will be able to, I hope you remember. So we need to have this global statement. So if I execute this, so can someone say what will be the output if I execute this, the whole code? Global s, then this. So basically after the first code I have added this and this. So what will be the output? So what will be the output of this? Come on. What will be the output of this? Is it not
Sir,
clear?
after writing the global statement over there, the S becomes global. I mean, whatever is outside initially, that will only be there.
No. So look, global s. So let's
Sir, is
look
it
at.
local SF to global S and global S?
Sorry. So first of all, this statement will be printing this, right?
Yes,
And
yes.
then this statement will, what will be?
Global
If
S. Global
global
S.
s, and this statement will be again global s.
I think so, yeah.
No. Why no? Because with this statement I am changing this global variable. As I have defined this global s, so without this statement, there is a global variable as well as there is a local variable, right?
Oh, yes, yeah.
With this statement I am referring to s, referring as s the same variable. So basically earlier in this case there are two s's, one is this, one is this. But after executing this, there is only one S, which is the global S. And with this statement, I am changing that global S. So basically, I am changing the global S. This statement has been changed to local S F1. And then I am changing this this S as well to local S F2. So if I execute this, oops, sorry, no, by okay. So again, I mean, together this local and sorry, global and non-local will be unable to we will unable to use them. So if I just comment this out for the time being, we can see this global S. So it should be better if I print the value of S here. So without this, there will be an error because here S is unknown, right? So after calling this F1, the first statement I am executing is print S, but S is unknown here. So to get this corresponding value, what we need to do is we need to execute this statement. We need to have this statement global S. So now S is known to this function. So now if I print this S, it will be global S. So first this statement will be printing. So this is the global S. Now I am changing that global S to local S. So if I again have the same print statement here, it will be, so this statement is printing. So let's have this like this, 1, 2, 3, and let's make it say 4. Okay, so 1, you can see it is global S. Now I have changed that to local S and F1. So the second statement is printing this. And now this local, this statement I am using, so this is one local variable, right? So use the same global thing, we can use the global here as well, global S. So now I am changing that, changing the same global variable S into local SF2. Now you can see the final output is also local SF2, which was the global output, global S. Is it clear? I mean, it's very interesting. As you can see, there are so many. I mean, there are so many questions that can come from here. So, how to use the global variable? How to use the global statement? And so many things. So, can someone say why this statement was not working here?
So non-local means global. Is it like that?
No.
But it's not
Non-local
local,
is
no.
not. Sorry.
I mean, global means it's available in the entire
Global
thing.
means
I mean,
this. Okay, anything
yes,
defined outside,
outside the program, yeah.
defined globally, from anywhere it is accessible.
So non-local
But
means
this
it's not
non-local means
localized.
it is not localized, but it is not
Yes.
global. Non-local does not mean it is global.
Why the
So
converse is not true?
the converse is not true, correct. So basically non-local S is expecting one S which is not global but not local as well. So it is expecting some S defined here. But you can see from here I'm using this global S, using this statement. That's why this and this cannot go together. So either we need to, if I comment this out, so now this local S, so basically this S, so again this is unknown here. So here this is the local. So in this program statement, there are two S's. One is this S and another is this S. And as we are executing this non-local S, this S, basically this S is referring to this. And if I use this statement, global S, this S will be referring to this. I hope it is now clear. Isn't it?
Sir, it is just like a subset of global list, right?
Not subset. I mean,
I mean it like global list also contains a non-local part, but non-local
no,
doesn't.
global S does not contain a non-local part. So again, I am repeating from here, non-local means it is not global. but it is not, I mean, it is not defined in this statement. So basically non-local will be something not global as well as not defined here. So basically here, anything defined here. But as we were having this global S here, so the non-local, from here the non-local S is something that is defined here, but there is no defined S here. So the only S available here, which is a global variable. And global, as I have already stated, globals are not locals. So that's why this statement and this statement will be unable to, we will be unable to get them together. So if I execute this, you will be seeing no binding for non-local S, because so you can see from line 8. So from line 8 it is the error, because non-local, so it is expecting something that is defined here and it is not defined. I mean, no
Sir, sir,
local S.
it would have worked if we had another function f3, right? If after f2.
After F2, if I declare no, so after F2, if I have another define say F3,
Yes, sir. Yes, sir.
no, then also it will not be I mean, it will not be working, because here there is no S.
Means we will define a s here.
If I define some S here, and from here you will be able to.
Okay. Yes, sir. I understood.
So if I execute this, you can see this non-local is considering this. So now, as you can see, now if I just print them, print s, oh yeah, okay, print s, you can see this this non-local s is actually considering this. Oh, this is a, okay, okay, so this is a good thing to look at. So you can see this non-local s is not considering this. So this non-local s is actually considering this global one. Oh, surprising. I am doing something wrong here. No, I hope not. Oh, actually it is not actually considering anything. So we can see there is no output as such coming
Sir, you
here.
have not defined in f3 as
Oh,
well.
sorry, we are not actually calling. Oh, extremely
Yes.
sorry. Extremely sorry. So if I execute this, F3 is not defined. I need to define F3 first. So that's why what I need to call is to call it from outside. Now it is S here. That is, this S here is inside this. So this S here is basically this non-local. Yeah, it is exactly what we are expecting. So this non-local S is considering this one, not the thing outside or not the global thing.
Sir?
Yes.
Sir, if we had only one function, like only F1 suppose,
Mm-hmm.
and then in that case the non-local and global will become the same thing.
No, really?
It will, I mean, non if we have
Non-locals
one
are not. So if I just have this,
so it is not, then what will happen? I mean, there is neither nothing outside nor inside, like
no, that's exactly what I am saying. Non-locals are not globals. Non-locals are not locals, but they are not globals as well.
they're
So
in between
here,
actually.
exactly.
Okay,
So as we
okay.
have seen in this example, so this statement, as you can see, let's remove this. It will be easy to understand. So here I'm defining, I have defined one F1, I'm calling that F1, and using this non-local, I want to access this, which is global. But if I execute this, you can see no binding for non-local S, because there is no non-local S here. But if I comment this out, if I use this global S, it will be considering this. So if I execute this, you can see this is the global S, and outside it is same, the global S. It is clear, right? I hope.
Yes, sir. Yes.